Okay, so we just determined that this reaction is not spontaneous. For a reaction to be spontaneous, delta G, hang on, delta G has got to be negative, okay? So the only time this is spontaneous is when delta G is negative, and that is what determines whether or not a reaction is spontaneous. But this one isn't. So how do we determine what makes it spontaneous? Let's remember that we said that delta S is disorder, and that higher temperatures of course means greater molecular movement. So molecular movement. So disorder is always greater. Disorder is always greater at higher temperatures. And so we already determined that this reaction is not spontaneous. We had a delta H of positive 176 kilojoules per mole. We had a delta S of 0.285 kilojoules per mole kelvins, and when our temperature was 298.15 kelvins, delta G was positive. So what we want, sorry, I'm trying to write the word positive here. So what we want is determine at what temperature, because we know that temperature increases disorder, at what temperature would delta G be negative? Whoops. Let's review this equation because we know it looks like this. Delta G equals delta H minus this quantity T delta S. So if we keep increasing the temperature, that's going to make this whole value in these parentheses greater and greater. And of course, if we're subtracting a greater and greater number, our result will be a progressively smaller and smaller number, eventually, hopefully, becoming so small that it is less than 0 or negative. So here's how this works. What we want to find is what temperature would make delta G 0. In other words, if we make delta G 0, then what would this temperature have to be? What value would we have to plug into this to make delta G 0? And then, of course, any temperature higher than that would be spontaneous. So let's take a look at this equation now that delta G equals 0. If delta G equals 0, well, let's take care of the T delta S. We're simply going to add the quantity of T delta S to both sides. So now what we have is T delta S equals delta H. Well, what's T? Delta H over delta S. You already know delta H and delta S. They're right here. You already knew them. They were given you in the problem. This one, the one that we started with. Not that one. This one. This is the one that we already started with. You already knew these values for delta H and delta S. All we're going to do is plug them right into this version. where in this version, let's remember, delta G is 0. So we know delta H, positive 176 kilojoules per mole. And we know delta S, positive 0.285 kilojoules per mole Kelvin. Okay, and aren't you glad we have these units? Because, of course, when you divide kilojoules by kilojoules, they cancel, mole by moles cancel. It's going to leave our answer in kelvins. Let's make that a little bit more. So, what is 176 divided by 0.285? And this will tell us what our temperature is in kelvins. 617.5 kelvins. No need to convert it to Celsius unless you want to. No need to round up unless you want to. But this is the minimum temperature at which delta G will be less than or equal to 0, and the reaction is spontaneous. Okay, that's the end of part 2.